Okay, so to use the second derivative test, we need to know what the second derivative is, and we also need to know what the critical points are. So, finding the first derivative, the 3 comes down, multiplies, that's just negative 5x squared plus 20x minus 15. And then the second derivative, nice and straightforward. The 2 comes down and multiplies, and then derivative of 20x is just 20. Okay, so we get the first and the second derivative, but remember the second derivative test needs to know what the critical points are. So we got to take that first derivative, set it equal to 0, and solve. So I'm going to factor out a negative 5 from everything. That makes my leading coefficient positive. I think I did that right. And so the parentheses can be factored. That's x minus 3 and x minus 1. So we got 2 critical points. X equals negative 1 and x equals negative, not negative 1, positive 1. And x equals 3. Those are the critical points. So what we did before was we checked the derivative to the left and the derivative to the right of each of the critical points, which takes a little bit of time because you've got to plug in some numbers. Now we have the second derivative test at our disposal. What you want to do is check the second derivative, see if it's positive or negative at these critical points. So if I plug 1 into the second derivative, negative 10 times 1 is negative 10 plus 20 makes 10. It's a positive 10. So at x equals 1, we have a local minimum, just like in the last problem, because the second derivative is positive. And then do the same thing for 3, but this one's going to be a negative value. So you have a local maximum at x equals 3, a local minimum at x equals 1. Okay, so the second derivative test says if you get some critical points, like if you take the derivative, you set it equal to 0, and you get x equals negative 7, negative 2, and 7. And if you have the second derivative, positive second derivatives at critical points are local minimums. Okay, so this is a critical point. The second derivative is positive, so that means negative 7 is going to be a local minimum. Same reasoning for negative 2. So that's the second derivative test. So 7 would be a local maximum because the second derivative is negative. This one here, we've got to do some algebra for this one.